Hello everyone. Let's start our today's lecture. We will discuss equations of motion. So there are four equations of motion. Some of these we have discussed in O levels, and now we will continue in AS Physics. So let's start. Start from acceleration. Basically, acceleration is defined as rate of change of velocity. The formula of acceleration is A is acceleration, which is equal to change in velocity. The word rate means divided by time. So acceleration is rate of change of velocity. So also you can write the formula of acceleration by symbolically A is equal to final velocity minus initial velocity divided by time. So from this formula we will get first equation of motion, which is if we make the subject v, so you will get v is equal to u initial velocity plus acceleration multiplied by time. So this is the first equation of motion which we have discussed in O levels. So let's start for second equation. Second equation is we know that according to definition of distance, the distance is speed multiplied by time. But symbolically we can write distance is d, which is equal to s multiplied by time. When we use this equation when speed is constant, if speed is not constant, then we use this formula by changing d is equal to average speed instead of speed. Average speed multiplied by time. Formula is same, but speed is changed by average speed. So we will get the average speed. We know that we can find the average by using s is equal to average speed is v plus u divided by the quantity of speed 2 multiplied by time, uh, which is equal to t. Now let's go for third equation. Third equation is new for AS level. So we will get this equation by substituting equation number 1 in equation number 2. So third equation is, first of all, I will write finalize equation, that is s is equal to initial speed multiplied by time, which is plus 1 over 2 half at square. We will prove this equation as third equation. Okay, we will start this equation by substituting equation number 1 into equation number 2. So let's substitute uh, v from equation 1, and we will put into equation 2. So let's continue. We know that equation 1 is v is equal to u plus at. By substituting this v into equation 2, which is equal to s u plus v over 2 multiplied by t. So we will put this v by this. So s is equal to u plus, by substituting v, which is equal to u plus at divided by 2 multiplied by t. So by substituting by solution, by solving this equation, we will get s is equal to ut. plus 1 over 2 at square, which is the third equation of motion. Now this is final last equation, which is v square is equal to u square plus 2as. This is fourth equation of motion we will prove. Uh, this equation can be proved by making subject t in equation 1, make subject t from equation 1 and put it in equation 2. So first of all, write the equation number 1, which is equal to v is equal to u plus at. So by making the subject t, we will get t is equal to v minus u divided by a. So this is the value of t. Put it into equation number 2. So the equation number 2 is s is equal to u plus v divided by 2. This is average velocity multiply by t. Uh, I'm gonna write into black because I will put this value with t. So the final equation will become s is equal to u plus v divided by 2 multiply by the t is equal to v minus u divided by a. So by solving this equation, we will get the final equation, which is equal to v square is equal to u square plus 2as. So this is the fourth equation of motion. So these are the four equations of motion. Uh, the first two equations we will discuss in O levels, and equation number 3 and 4. It is a part of AS level. These equations can be used. These four equations, which are equation of motion, can be used by following conditions. Okay, there are two conditions in which we use equation of motion. These conditions must be satisfied. Number one, object must be moving in a straight line. Just like car is moving on a straight road. This is the example of linear motion. And second condition is the acceleration of object must be constant. Acceleration of object must be constant. Means the velocity, constant acceleration means the velocity is gradually increased. So these are the conditions. Now we will discuss the topical question related to these equation of motion. So the question is, let's suppose a body is moving in this direction with 40 meter per second speed. After covering a distance about 60 meters, its speed decreased to 20 meter per second. And after what distance its speed is zero? I mean, it's come to rest. After what distance? We'll find this distance. we will use equation of motion in this situation. So first of all, we have two parts of this question. Number one, we will use this velocity and this distance, and we will find the acceleration, which is deceleration. And with the help of deceleration, we will find the distance. So first of all, let's put v square is equal to u square plus 2as, because we have not given a time, so we will use four equation of motion. So putting the value, which is v square, this is the final speed and this is the initial speed for this case. So v square is 20, which is square is equal to u square, which is 40 plus 2, a we will find, and distance is 60. So by calculating this equation, we will get a is equal to minus 10 meter per second square. So we will use this value to calculate this distance when a object is rest from 20 meter per second. So we will use again fourth equation. V square is equal to u square plus 2as. V is final velocity, u is initial velocity, while a is acceleration and s is distance we have to find. So by substituting this value, in this case, this is the final speed, this is initial speed, and acceleration is this. So v square means 0 square is equal to u square. U square is 20 square plus 2 times a. A is minus 10 multiplied by s. So by calculating these values, we will get s is equal to 20 meters. So this is the required distance, which is 20 meters. It means after covering 20 meters, the car or any object is rest after 20 to 0 seconds, 0 meter per second. So this is the lesson about equation of motion, and this lecture contained one topical question and two conditions.